Everything it has been said with respect to the bitstream relocation technique is great, but we do have just one small problem. The FPGA are not homogeneous devices. As we all know, they are composed by a set of heterogeneous components. Therefore, how can we get any benefits by implementing a bitstream relocation technique? Well, again, not an issue, an opportunity. It is true that FPGAs are heterogeneous devices, but getting closer to them, we can see that there is a sort of a pattern in their heterogeneity. This means that we can leverage on those patterns to create a virtual homogeneous device. In this figure, we can see three different resources represented by three different colors. Configurable logic blocks have been implemented in red, RAM blocks in blue, and input-output blocks in green. We are now going to have a scenario where, no matter what, everything is going to be homogeneous, but we may have areas that are going to be homogeneous with themselves. Let me show you an example to better understand this concept. We do have three functionalities that are represented as the previous one. Now, for each of them, I'm going to define the shape of the area that can be used to implement the reconfigurable region able to implement the corresponding functionality. Each functionality will be then implemented generating the corresponding bitstream file. So far, there is nothing new, but this is exactly where the idea of defining virtual homogeneous device is coming into play. Let me consider just one of the previous three functionalities, and let me use, as an example, functionality 2. I defined the area to host it, and I've been able to implement it on my FPGA. Now, what I'm interested in finding is if the reconfigurable region I define can be found onto the FPGA in just one specific place or more. As it can be seen in the figure, we have 6 areas that are providing me the exact set of resources I was looking to implement my functionality. Now, saying this does not imply that I'll be allowed to relocate my functionality at runtime from one area to the other. There is more that has to be taken into consideration. At design time, I had to implement a system capable to support the relocation. As an example, by creating the proper communication infrastructure, and by implementing the necessary input-output interfaces in each candidate's region. This is once more a great example of how, while working with a reconfigurable device, the runtime and the design time are cross-fertilizing one the other. It's really difficult to identify a clear separating edge to differentiate the two phases, and this is making doing research in this field even more interesting and exciting.